Right, so as I said in the previous video, there's actually three different ways of solving a quadratic equation. We could either factorize it, we can use the quadratic formula, or I said we can complete the square. In this video, we're going to go into more detail of how to complete the square. In the textbook, they actually do give you the general form of the completing the square, but I would always recommend you not to memorize this, but just to understand how to do it. Anyway, we still need to know the derivations. So if I have the general form of a quadratic equation, ax squared plus bx plus c, and I'm going to say a is 1 for this one. So I have x squared plus bx plus c. Now what we're going to do is we're going to concentrate on this x squared plus bx term. The c term we'll ignore for now. We're going to bring it back in later on anyway. So x squared plus bx. I'm going to divide the b by 2. I'm going to say x plus b over 2, and I'm going to square it all. If I now expand back out, I'll have x squared plus bx plus b over 2 all squared, right? What do you notice? Well, we've got this extra term, b over 2 all squared. So from this original, we have to subtract b squared over 4. Now we bring back the plus c, so bring it back in. We'll have x plus b over 2 all squared plus c minus b over 2 all squared. This is basically how they get the form for completing the square. But as I said, you don't really want to memorize this equation. We want to understand how to use it because it's much more simple. So let's look at an example. Let's say we have the example x squared minus 8x plus 10. The way I go about doing it is, first of all, I understand or I identify what our b coefficient is going to be, in this case minus 8. And I divide it by 2. And that's the value I'm going to put inside the bracket. So it's going to be x minus 4 all squared. And then outside the bracket, we subtract this b squared. So we're going to subtract minus 4 squared and then bring down the c, so plus 10. So in total, we're going to get x minus 4 all squared minus 4 squared plus 10, which will simplify to x minus 4 all squared minus 6. Let's try another example. Let's say we have x squared plus 10x plus 2. Okay, so in this case, b is 10. So I'm going to divide that by 2, 5. So we're going to have x plus 5 all squared. We subtract, it's always going to be subtracting b over 2 squared. So subtract 5 squared plus 2. So we're going to have x plus 5 squared minus 25 plus 2, which is x plus 5 squared minus 23. So if we look at the example here, we can see that the x squared coefficient is 5, no longer 1. So therefore, I'm going to factorize it by taking 5 out. So taking 5 out, I'll have x squared minus 3x, close bracket. I don't care about this plus 3 for now. We'll just leave it outside. We now complete the square for inside the bracket. So we're going to have x minus 3 over 2 all squared minus 3 over 2 squared, and then outside the brackets, plus 3. Now it's just a matter of simplifying it. So we'll have 5 times by x minus 3 over 2 all squared minus 33 over 4. You guys should just practice some of these because it's just getting used to it or getting the hang of it. Right, so that's basically how we go about completing the square. But as I said, we can use this to solve equations. So if I equate this initial quadratic equation to 0, that means all of this completing the square part is also equal to 0. So 5x minus 3 over 2 all squared minus 33 over 4 is equal to 0. Now it's just a matter of rearranging for x. So bring the 33 over 4 to the right-hand side, dividing by 5, we'll have x minus 3 over 2 all squared is equal to 33 over 20. We square root it. Remember, if you square root it, we have a plus or minus sign, right? So we'll have x minus 3 over 2 is equal to plus or minus root 33 over 20. And I'll bring the 3 over 2 to the other side. So x is 3 over 2 plus or minus the square root of 33 over 20. So that's just another way of solving a quadratic equation. The good thing about completing the square actually is it actually tells us certain point or actually an important point on a quadratic graph, which we'll look at when we're drawing these graphs.